All right. So I'll go ahead and minimize this. And we'll go ahead and get started with first, I'll overview Arivis Pro. And then towards the second half, we'll go into Arivis Cloud. To give you a very brief overview, before we go more in depth of each of the two, Arivis Pro versus Arivis Cloud. Arivis Pro, think of that as your local desktop application that you do your image analysis in. So you would do your segmentation, any pre-processing, get your measurements, intensity measurements, value measurements, etc. Make your movies, and then export all this data into Excel file that you can then run statistics on. So kind of think of it as like your Fiji or any other image analysis software. And then for the second half, we'll go and talk about Arivis Cloud. Arivis Cloud is a web-based a website where the only purpose of it is to develop and train a deep learning model. And so for that, I'll load like an example data set that we have and kind of briefly go over kind of what the best practices for creating a deep learning model is and kind of show you what that process is like. Okay. So we'll start with Arivis Pro. And when we load Arivis Pro here, we have this empty screen that we see here. And there's nothing loaded into this. So there's not really a ton of options for us to look at anything right now. So all of these are grayed out. And the first step of any time that you want to do image analysis with Arivis Pro is you will have to convert your file type into a native .sis format. And to do that, you would almost always start with a new image. You would go to File and then hit this Import button. And so when I go and hit that Import button, got some, I'll go ahead, actually, let me stop sharing for a quick second. Let me load an example data set here. Maybe I'll do this one here. There. Okay. Go ahead and share my screen again. Okay. So I went File Import. I found a file. Now I've already converted this to a .sis, but if you have, let's say, a .czi, or if you have any of these other file types here, so we can take over 50 different file types. So that's different forms of TIFF files. If you do any deconvolution and you have like a Huygens deconvolution output, JPEGs, PNGs, etc. So when you would select whatever file type that you're starting with, so in this case, CZI, I'll hit open, and then it's going to ask, in this case, because we don't have any images open already, we're just going to make it as a new file. And so this is saying this file, this .czi that we're importing is going to be a new file. It's going to be saved to, let me change this to another folder. And then this is the file name here. It's going to have the same name as the native file. And you can see it now has the tag .sis. We can also save with gzip compression. It's a lossless compression algorithm. Essentially, it allows you just to have a smaller, slightly smaller image size. And then we also have different import options. So we can do a custom import. And this could be useful. Let's say you have, I know light sheet data. I'm not sure if anybody works with light sheet data, but those can get really big really quickly. And they can get, to a terabyte within just a half hour of imaging. Maybe you don't want to import the entire terabyte of an image because that might take a little bit of time. Maybe you just want to look at your result really quick, or just look and analyze and see how it looks in a small section. This is where a custom import can be really useful, just picking a small ROI. If you're doing time series data, maybe just importing like a small time set. etc. Okay. So we would hit OK, and then it would convert it and pop open the image. In this case, because I've already converted it, I'm just going to open up that file. And so whenever you have a new file created and saved as a .sis, you can then now, you're done with the import option. You can now hit open, and then you'll see just the .sis is available. And you can see that that is, so we have this CZI, which is about 500 megabytes, and then the compression algorithm reduces it to about 270. Okay, so I'll go ahead and open this file. Oh, I kind of spoiled some of it. So I did some analysis. Let's pretend you didn't see that. And so we have our image opened here. Now you can see that all of these options are now opened up and available. And this is going to be what allows us to kind of work with, manipulate our images, and do whatever sort of analysis that we want. There is another thing I want to mention with import is, let's say that you are you want to analyze and run a pipeline, a single pipeline through on experimental data set you have. So let's say you have a control group, condition 1 and condition 2, and you want to compare them. One of the ways that I would recommend being able to kind of run through everything is, I like personally to have all of my images kind of saved in one single file. So this way, you know, if I have 6 in it for each of the 3 conditions, including control, I want to load all 18 images into this single file. It's just easy kind of data storage and navigation for me. And so one way to do that is you can go back, once you have a .sis file opened, you can then go back into import. You can then find a either, you know, those other 17 images that you have, you can import them. Maybe I'll do here just because it's going to yell at me. And then we now have these 2 new options that pop up. So a new image.
Are you okay?
Sorry, big question?
Oh, I'm sorry. My dog is sneezing. Sorry. Thought I was muted.
No worries. And so in this case, we can hit new image set or new channel. New channel, I think, is, you know, pretty explanatory. If you have, like, let's say a wide field image and it's broken down into your 3 channels, you can just import those through the same method. But I'm going to hit new image set, and then you'll see as it's importing it, we now have a new option up here. And we now have this option here. It's the same file, but I would repeat this option for the next, you know, however many images you want in your experimental data set. And then you can just kind of scroll through. And then it's all maintained for you right there. So when you go and you run a pipeline, you can then say, just run it on every single thing in this image set. I see someone in Teams, so I'm going to in. Oh, I guess they left. Okay. Okay, I'll save this. And then, so that's kind of covers really briefly imports. We also have import options. It'll read the metadata of your file. So if anybody works with like 96 weld plates, for example, and you go and you import that file, it will recognize that the metadata of that file, and it will automatically say, you know, this is a 96 weld plate, and then you can see some other sets here. You know, it'll say like well, A through Z, rows, whatever. So depends on the metadata of the file that you're going to import. We go and see. And I think that about covers. Let me see if there's anything else with import that I'm missing. We can do. I want to go to this custom import for a second, just to show you what this is. And you can see that this file is reading the channels that I have, the Z, how many Z planes that I have within it. It's not a time series data, so it's recognizing nothing here, etc. So basic metadata. If you have, let's say, images, and I know this is common for people, maybe you're exporting as like a TIFF instead of a native file format from, I don't know, if you're doing like stitched images, for example. One of the nice benefits with the import option is that, let's say you have your images and they're all named the same thing, and maybe there's like, you have it labeled by file name and then underscore field position underscore time point, etc. So one of the things that we can do is take in all of those images, and you can say, based on that file name, look in that data, look in that string, and now parse that data for, and you'll tell it essentially what it needs to be looking for. So if your images have, you know, maybe you have 20 images, and each of those 20 images is a single Z plane, you can say there should be 20 there. Do you have an image set that has maybe that file name is showing same name, and then it just goes from 1 through 8, and then it does. And we can add in maybe if you have different channels. So point being is that we can adjust these dimensions, and you can, if you have your data named a certain way, we can have the a string search find that data and then import it incorrectly. You can also see a preview on what that would look like. So in this case, because I don't have any time series data, this doesn't make sense, but you would then be able to kind of see, okay, that this is reading my first plane, it's going through for all the time points, and now it's going to the second plane, going through all the time points, etc. Other thing would be pattern matching. So this would also be, if you want maybe a little more manual way to do kind of the same exact import and stitching and everything. So instead of, or I shouldn't say stitching, it's more, I guess, reconstructing the image. And let's say like applying that dimension order is not recognizing it, you can then do pattern matching, where it'll give you a little key for how you should write the data and kind of search the string. But this would also be if you have a certain file name here, you can see that it's recognizing that it starts with this FL and then it has a number here. So then it's saying, you know, maybe this number, it's recognizing this as a channel index. And then, you know, we see a B here, underscore P, and then it's now, because there's another number here, it's looking for, let's see, %P, so it's looking for the plane index here. So it's thinking that this is the same plane. So it doesn't make sense now, but, or at least this doesn't make sense with this file name here, but just want to let you know that that's, you know, kind of some ways to import the data as well. Okay.
Hello, Brenna.
Hi.
What does that input X and Y, what does that value mean if you go back to the window?
Let's see. Go back to CZI, go back to import. This here.
Input X, yeah, the 75,000, 752,000.
Yeah, so this would be the XY coordinates of the image. So you can see that for this, for example, this X, my guess is that there's 752,000 pixels. So if I go over here, this is one way that we can view the sum of the metadata associated with the image. And you can see that the bounds of this are those same numbers. So let's say I want to import maybe just like this top half, then I would find what that value is for half, and then we can go and adjust that Y value.
That should be the input width and the height, right? That's the frame size for the image, right?
So I think this would be, let's see what it says. So this would be the pixel itself, and then image. Oh, maybe there's an offset associated with it. There is. So this offset, my guess, then this user, this data that we have, they did some sort of offset while imaging. We can actually go, it doesn't affect the data really, but we can go and set this to 0. And that makes more sense. And then we have the, so 2700 pixels by 2700 pixels. We have the pixel size here too. So we can kind of get like the width scale to the pixel size there too. But yeah, that offset is, might be useful for some applications. I haven't ran into an application where I've actually taken advantage of offset. Usually I just reset it, because sometimes if you're doing like deep learning or any segmentation, sometimes that offset can kind of throw you off. There is a kill and run assay for people who are looking at tumor cells and T cells, where when we're doing that time-lapse tracking of those objects, that offset kind of slows it down a little bit. That's one application I can think of where you just want to reset this offset.
Okay.
Let me save that too. Right. And then you can see that it resets there. So while I'm here, actually, I'll go. So we have our image opened, and then down here at the bottom, there is a few options here. So we have this viewer, 2D viewer, what we're seeing right now. If I go back over up to the top right, this is also going to be my navigator. So here I would navigate through the image sets that I have loaded. And then this scroll bar here is going to be scrolling through Z. So take it, move it, Z. If I want to see it all as a gallery, so I see the 17 Z planes are now overlaid or laid out in a gallery view here. This is a 3D data set, so I can then hit this third option, this 4D viewer. We don't have any time dimension here, but we can now see this small Z stack. And then we have metadata right here. Let me go ahead and shut this off, actually. And then in this metadata, we have, what you'd expect: file name, where the path's located, file size, the bit depth, pixel size, and then the scaled scaled image. We have our channels here. So if we want any more information, because this was imported from a .czi, it also maintains that CZI metadata. So we know that this was imaged on an Axio observer. We know the objective that it was recorded on. So chances are, well, if we do accept the native file format, again, we accept over 50 different file types, it'll import whatever is native to the metadata of your image. So if you're imaging off of the Leica, if you're imaging off of the Nikon, we'll also be able to import that data as well. Okay. Also scroll through your images in here, image sets in here. And then we have in this last tab here, this projection viewer. So let's say I just want to update this. This would be a max intensity projection. Update this without that channel of our Z planes 1 through 17, and then all of X and all of Y. Okay. Different viewers here, depending on one. I think there's a way to maybe a larger section of this too. There we go. So now we can see, kind of small to tell here, but we can get also a different view of the data, rather than just, in this case, it's just top down. So we have different projection scenarios too. All right. Go back to this 2D viewer. When viewing the data, I'm going back on this right side over here. You can see for each of these, well, I guess there's 4 channels, but I'll turn off this PMT. For these 3 channels here, we can see it's 8-bit, so 256 levels. And then we can adjust the histogram of these. So right now, If I were to hit auto, for example, it will, so it's saying calculate the auto color range for the current plane. So if I am putting my scroll all the way down to this area, you can't really see much of anything. And if I hit auto, it's going to kind of oversaturate everything. So now if I go to this middle view, this looks kind of oversaturated, but hit auto again, it'll scale to whatever plane here, or we can just do it manually. Etc. Okay, you can also turn off different channels right here. If I just want to look at this green channel, for example. And then we can adjust gamma here as well. Okay. If I scroll down a little bit more, should I go this now? I'll go over these these other settings in a little bit, but that'll be related to creating movies from this data. So I'll go back to that. Down here, we have a couple more options. One is any objects. So let's say you've ran a segmentation on your data, and now you have these segmented objects, right? We have this really easy toggle on, toggle off. I might have, it'll take a second for this to load. But once you create these objects, you can just toggle them on or off. I think you might have seen them pop on in the when I first opened the image file. Really easy way to just kind of hit this on and off. I see Maristella is trying to get into the Teams. I'm not sure if anybody's able to send the link to them for Zoom, but that would be great if someone could. And I'm wondering where I might have gotten rid of my objects, or oh nope, it's in this one here. Okay. So we can toggle on and off our objects. I've already went ahead and done some segmentation on this. I'll kind of walk you through that pipeline in a minute. The other thing I want to point out is that we can also, you can see that there's a scale bar right here. So on and off. And then if you have any time series data, you can have that loaded there. And interpolate is kind of like a smoothing. So if I zoom in, it's going to take a second to load this. But we can zoom into and see the actual pixels themselves. And this is really useful for when you're trying to segment objects out. It can be kind of annoying if you don't have the best resolution or whatever. It's kind of easy, I think, to have access and visibility of the individual pixels. Because then when I'm going to segment out something, let me find like a really clear example. Maybe I'll turn off all of these here, and I'll zoom into maybe this dappy here. I now know exactly, based on the pixels, where I want to kind of circle. So up here, I'll go over this toolbar in a second, but there's one option to just manually create objects and draw them. So I can now just look at this actual pixel data. Now I have an object right there. Turn back our object. And it looks like that's actually kind of similar to where, oops, don't do that. Get rid of this manual. Go back to this. You can see it already kind of did it though. All right. The other thing I will point out too, with this scale bar, we have a couple of options to, right now you can see it's kind of static, right? Like no matter where I zoom out or zoom in, it's always staying at that 100 microns, which is a huge scale bar. And I don't want that. So what we can do is go up to, let me find it. Preferences. There's this. scale bar setting here, and you can see that it's right now set on a fixed size. And we don't want that. Unless you do, it's actually really useful, I guess, if you I always did like 20 microns or something like that for my papers. But if you want to do a dynamic size, you can see it updated to 20. I can hit dynamic size and hit apply. And you can see now, depending on where I zoom in, it's kind of adjusting accordingly. Okay. And I'll go back into that preferences towards the end. And then interpolate is, I think I kind of mentioned it, but this is kind of like really just smoothing, but it's not going to adjust the data. Oh, and I want to also mention that any of this data, let's say you do some pre-processing or any sort of manipulation of the image, remember that we created a .sis file, so it's a totally separate file that's just a copy of whatever the native file you imported it from. So you're not going to overwrite your data or change any of the pixel information. Same thing with this .sis file. It's hard to change the pixel data. None of the preprocessors or preprocessing steps stick to the data. You can output the results and kind of save it separately, but if you do any sort of pre-processing, once you complete your pipeline and you get your objects, it's going to revert back to the original pixel intensity information, all that stuff before you pre-process it, kind of that raw data is going to be reverted back to the original. Turn off interpolate. I don't always like having interpolate. Maybe for images, if you're taking like a screenshot, it can make it look a little nicer. But personally, I think it's useful to just see the pixels themselves, and they kind of blur away and get lost in the background if you get far enough. I'm going to go up to the top up here. So we right now are looking at a single view. We can also do a split view. And there is also a way we can link this, and then we can do figure out how to do this. Also preface with, if there is something I'm not sure about or question that I can't answer, I'm going to write it down, and I will follow back up within a day with that information. And if I don't, please bug me and hold me to my word and make sure that I actually get you that information. But there's also a way, and I say that because right now I'm forgetting how to do can do a new image set here. Oh, it's because I have it linked. There's a way we can load 2 different images, and you can look at this in 2 different views, which is what I'm doing now. So we have these 2. So we have the split view. You can kind of change it however you want within these options here. And you can see I'm kind of scrolling through one, click on this, can scroll through the next. So this is useful. I find it's useful when I guess if you're comparing like 2 different types of data, if we do like a experimental and a control condition, and you want to do like some annotations or some segmentations, it kind of helps to know where kind of what stands out, like if you're testing maybe a certain drug on neurons and you have your control condition and experimental condition, and the neurons look completely different in the experimental condition, it kind of helps having these 2 to compare. Alternatively, you can also just hit File up at the top here, New Viewer. It's going to bring the same 5 options that you see down here. So I'll go hit File, New Viewer, and then you can just open up a new image this way and then kind of do it something like this. Either or works. And then we can also do a link this view. So when I hit link, it's going to move them both together. So this could be useful if maybe you want to look at each of your 3 channels split separately, without them kind of overlaying on top of one another. It could be useful. Okay. Then you can change kind of your workspace layout. This is just personal preference. Okay. I'm going to go back to a single view, go back to this default data set here. And I think that covers a basic overview of tools and buttons that we can click. Okay. All right. So now we have our image loaded, and we want to do some image analysis. Actually, before I do that, I'll go over kind of these buttons up here, toolbars. So obviously there's our file. Can do, again, our new viewer here. And I do this all the time. I usually, before I had this open, before I started the Zoom, I had like, I don't know, I usually have a bunch going at once. And you can run analyses or do your segmentation and trainings on these kind of, not simultaneously, but while maybe you have a pipeline running in one, you can then go and pull out and quantify your data in the next, another image, another 2D viewer. Or maybe you can go and take all of that, get just the measurements that you want and export that while another pipeline's running. Can then do open recent, self-explanatory, any files that I just recently opened. There's also an export option. And one of the nice things about this is that you can export it as a native CZI or a CZI. If it's native, if you import it, then it would be. But you can also export as a TIFF, or you can export it again as a .sis. And then you can choose kind of how you want to export it. So if I did TIFF, hit OK, we can choose to, if I want to split these, in this case, it's an OME TIFF or a multiple TIFF files. If I want to export multiple TIFF files, like let's say I have 100 Z planes of 3 channels, that would be 300 TIFF files that I would have. And that could be useful for splitting all of those up for when I want to go and, let's say, train a deep learning model on Arivis Cloud, which we'll get to in kind of the second half. And that is going to accept CZI, I mean, same file formats as we would accept in Pro, with maybe like a couple of exceptions, but it would always convert it to a CZI. So, instead of having to like go one by one and export your data, it's kind of a really quick way to do it. And then you have like a training data set you can train deep learning models on really easily. You can also choose to pick a certain subset of that data. So again, you can do custom here based on the Z planes, and then you can choose where to save it. Close out here. And that's pretty much it for there. We have this undo and redo button also right here, super useful. We can also, there's a really quick screenshot option right here, or you can hit this camera button right here. Same thing. Sometimes there's some buttons that like have, they're in a couple of different places. For example, this undo and redo button. And then this view, I'll kind of go over this view more so when we go into that, like creating movies. But these are going to be a lot of the same options that we would also see down here that I'll go through in a little bit. Can also toggle the legend here. I think this is all pretty much, so these are going to be the same 5. This data, I think, is actually, these do have some adjustments or some functions that are just located within here, one being pixel size. So sometimes, let's say you have like a TIFF file that you're importing, and maybe the metadata isn't saved onto it. So, the software can understand that this is a 16-bit image, has 65,000 whatever grayscale values, but it doesn't know what the size of the pixels should be. So if you don't have that information, you can just manually change it yourself. So again, this was imported from a CZI, so it's already maintaining that metadata. But if you're importing from a TIFF and it just defaults to like 1 micron by 1 micron by 1 micron, you can then adjust here. Okay. There's background correction, depending on kind of how you want to, like the algorithm that we want to use. I personally don't use it this way. If anybody wants to try it this way, but I think doing background correction is actually easier just running it through our pipeline in the analysis panel, which I'll go through in a minute. There's this transformation gallery, which I think is actually pretty useful. So these would be a case of, let's say you want to crop this data. Really easy, just drop and drag this ROI. We can hit OK. So I'll do that for an example. And now anytime I do any sort of these adjustments in this transformation gallery, it's going to actually create a new image for me. So it's not going to take this file that I started with and crop it and replace it. It's going to crop it and then copy it. So I now can click this third image set that I have, and we have this crop view right here. Still in 3D. You can also choose if you want to flip the data, resampling it. So this could be useful. I resample and upscale my data a lot. So instead of having, for example, like maybe find like a bright area. So instead of having like, I don't know, let's just pretend there's 100 pixels here. We can artificially upscale it to where we can then take this, maybe instead of being 100, it's now representing this within 500 pixels. So it won't necessarily improve your resolution, but having more pixel information can sometimes help the algorithms, especially with like training data sets or with accuracy of segmentation. Okay. Any sort of rotating you want to do. Oops, how do I do this? Oh, wait, do it here. And then if I wanted to say, let's say, rotate this and then just get the first 10 planes and then get maybe just channels 1 through 3. I don't want that PMT channel. Like this here, you can then see it'll automatically update here. You can choose the quality here. One of the nice things too is you have values that are associated with these. So you can adjust using a set value, but I think this is useful for when, let's say, maybe I'll use, the example of cropping again. So we can see we have our bounds here, but let's say I want to do like a nice even split through the center, like pixel perfect, right? So I can take it and let's say I want to break it up like right here and right here. I know what these values are. So I know that this bound starts at this value, ends at this value. And so what I can do is just say, to get a perfect crop, go to the end, replace this. Bam. Now I have an exact pixel perfect crop. So this way, no information's missing. No overlapping between the ROIs can happen. Maybe useful for some people if you kind of want to have like really precise control over that. Reset this. These are just different ways of viewing the data. So zooming it, change the projection, quality, etc. We can also rename it here. And I think that about covers transformation gallery. We also have some other options. Drift correction, if you have some drift that's happening across channels, you can manually adjust those. Also have this volume fusion. Let's say you have two different, let me think. So let's say you have a assay or long-term imaging session that you're running, and you are doing a 24-hour imaging session, or at least like you have your sample set up, image it at hour 1, wait 2 hours, image it again, etc. And you have like a bunch of different images of the same ROI that you want to now combine. You can do this volume fusion. think of this as like your registration. So we can then do a linear transformation to take these images, overlay them on top of each other. And then you can also kind of see what that's like. This is the same image, so they're just overlapping onto each other right now identically, so can't really see that. But we can do a manual registration, or we can say use landmarks in the image to register this data. So let's say you have an organoid, and maybe there's a little bit of drift that happens, but you still want to register all of these images together using that organoid. So if you segment out this, like you can see we have this cell here. If you want to now create a whole object around this, and you can create that for each of your images, you can then say, using this object that I created, overlap and adjust the image so that these objects are overlapped. Okay, and then you would see the result in here. And again, yeah, I think I mentioned we can do it manually as well. Tile sorting, if anybody works with wall plates. Let's see how this looks. It's not a tile image, but so it's not going to be quite looking how it should look. But if you do have all of these like 96 wall plates, you can then say, you know, I want to drop and drag these into certain regions. You can do a alignment using an algorithm or some. So in this case, you have a few different algorithm options here. You can also batch this. All changes. Yes, I do not want these. And then these are the same options that we see over here on the right. This edit structure right here. If you want to delete any of these image sets, this is where you would go and do it. So remember, I have these 3 different image sets here. The one that I imported, again, is new image set and the cropped. Or maybe I don't want this PMT, so I can go, this PMT channel, so I can go and delete it. I'm not going to delete it. Or if I want to get rid of some planes here, maybe just, I don't know, there's some error and I don't even want to deal with it anymore. I can just delete it this way. Then same thing here. This is kind of a well plate editor. Kind of the same thing where if you have 96 well plate, you need to adjust these. You'd have them all listed here. So you have your 96 image sets. And this would be the case of where you aren't importing from like a native file format of whatever 96 well plate, whatever that native file format is. This would be if like you're importing from a TIFF and you need to kind of, you lose some of that metadata and you need to kind of reconstruct. I think that about covers data. Navigation is, you know, you can go and navigate the same way using this panel over here. And then objects are, maybe we'll go over objects when we go after our analysis. And then analysis here, we have this analysis panel, this little beaker. You can see the same little beaker over here. There's also options for, I'm not sure, I think I'd have to go back and look if you guys have also included deep learning, deep learning, a local deep learning trainer. But this would be loaded here if you guys have that, and then machine learning would also be loaded in here too. I can go through, maybe I'll go really quickly through it now. So let's say I want to segment out some DAPI. So maybe these brighter regions. And doing just like an intensity based operator is probably not going to give me the best result. Maybe I'll do something. this because there's a little bit more discrepancy. So let's say I want to like segment out this little piece of it, but this object, if I were to do an intensity threshold, this is going to be, if I did choose to include this, then probably a lot of this other information would also be included, and it's just going to be a mess, right? You're only segmenting based on one feature, intensity. Machine learning, the advantage is that it's quick, number one, but two, it is a really sophisticated pixel classifier that uses multiple features rather than just one. So when I go and I hit this machine learning trainer, it's actually pretty simple UI. So the first thing you'll load it, you have this voxel training, you can name it whatever you want. You have this little warning sign saying, hey, this model is not trained. You need to do some training on it. And then you have the options to pick what channel. So in this case, if I want to just do a segmentation of this red channel, I'm just going to pick the red channel. And then we can pick our feature selection. So if we hit this, one of the pre-canned and pre-made ones, or we can hit this feature here, go to custom. And then I can say, there's 28 different features here. So let's say I want to keep everything for intensity, and then we have different kernel sizes. And so what this means is that when I go and let's say I put a little annotation for this class here. So I'll rename this red. I'll put a little dot here, dot here, dot here. And I can go to my background, say I don't want this background. So for each one of these little tiny annotations, these spots that I put, these features are saying that it's going to be, these are different size kernels. And so it's going to be looking for intensity from these annotations.
So, Brandon,
yep.
What decided the kernel size?
One more time.
What decides that the kernel size is like? Can we change it?
The only options for the kernel sizes are going to be the 7 options that are here. So this would be from 21 nanometers to 710 nanometers.
And this is decided by the pixel size, or?
I'm not sure, actually. Maybe I can go and let's test that. So if I go and I change this pixel size to something really large, my guess is yes, but I'm not sure. Let's check. So we've adjusted this. I'll go back into my machine learning trainer. So because I changed it, we'll have to do a new training, and then yes. So it is based, kind of, it looks like it is based off of the metadata, but if you remember before, it was up to 710 nanometers and 21 nanometers. So it does look like it has like set values, but they will scale to some degree off of that metadata.
Okay.
And usually I don't include this. Maybe I'll go back to original metadata that we had. Oh, that's not going to be right, is it? Let me do this. Discard these changes, and then we will open it back up. There we go. And I don't think these would be saved, but for whenever I do select my features, I usually do exclude the largest kernel. The reason being is because it's a large kernel, so it's going to take a lot of computational time comparatively compared to, this 21 nanometer, because it just has a wider region to search out for and compare and test these pixels. It doesn't always offer the biggest benefit, I feel, at least in my hands. And I'd rather just save a little bit of processing time if the result's not going to be that much better. And also, I usually do get rid of this orientation because for most people's applications, their cells aren't going to have a specific orientation unless you work with like filaments or any sort of structure that does have certain like directionality and orientation is important. But because these are just cells, there's not really there's no orientation that's going to be pulled out from this. And this will also save us some processing time. That's usually, there are some cases where I will change these and include orientation. I don't think I've ever really included 710, unless you have like really, really, really large images, like a couple millimeters of like skin tissue. Maybe that would be pretty beneficial then. Do it on just one channel. I have my custom set, and then you can see I have my, oops, thought I changed it to red. We have our background in red. We can add more classes. It's personal preference, but let's say we wanted to do machine learning to get out this red channel and do machine learning, and you also want to get out maybe this DABI. You have the option to say, add a class, make this DAPI, and then add this channel into it. Oops. But again, it's personal preference. I don't think there is, it might take a little bit more training for the segmentation to be good, just because it's learning on, or sorry, it takes a little bit longer to train it, and maybe a little bit longer to run it, because it's now looking at two different channels at once and then doing this comparison of the pixels on the red channel and doing the same thing on the DAPI channel. Usually I just create separate training. So what I would do is say, okay, I have my one training for red channel, and then I would go and I would do a brand new training, do it just for this DAPI. I'll do for this custom. And then I would just run them both. So I would do step one, run this here just to have something in here. So I would do step one, run this DAPI, step two, run this miter red, rather than saying step one, run both of these at the same time. Okay. Go back to this red channel just because I have slightly more annotations. And then once you do just one class annotation, so this red channel, and one background annotation, you now have the option down here to preview three different options. So one of them being the result. So this result here is going to be, if I were to run this right now, this is what my result would be. And this is really useful because I'm not sure if anybody has done any sort of custom deep learning training or machine learning training, but it can be frustrating to do a ton of annotations and not have any guidance on where to annotate next, right? So if I could go and I could add in red. I could go and add a ton more of these red annotations to this spot right here, right? But it's not improving the model at all. It already recognizes this. It already recognizes this object. So why would I add more annotations to this? Because it already has it right. So having this preview lets you know, okay, you don't have to annotate anymore in this region because it's already got it. But let's see where else it's messing up. So maybe I do actually want this little piece over here. So now I would annotate that. Maybe this is like a little bit too out of the boundaries. Maybe I just want it like this. So now I'm going to do a little bit of background right here. Without this prediction, if I just do something like this, I have no idea where I should annotate next. I can do this, I can do this, I can do that, but it already knows this is background. So there's not really a point of me adding in all these extra dots right here. So I find this to be pretty useful. You can also do this probability map. You can change the opacity, which I think you just saw me do. And then we can also change the, fine tune these results. So if I want to now really smooth this over, you can see it's kind of grabbing all of this information. Let me just get this. Some more background here. Oh, and one other thing, the previewer on here is just a approximation. It's not actually running the algorithm. So the further I zoom out, it actually is going to be less accurate, the preview. You can see how it kind of looks like it's getting everything right. The closer you zoom in, the more accurate that result is going to be. Just a little FYI. But now if I go and I smooth this, it's probably going to look like just a big blob and not super yet. So it's really just getting these cases of where they're roundish, smoothing all this information. Same thing with threshold. My guess is that it's going to be a little more stringent with the criteria that it's including background, foreground. So if I do this threshold, it's going to probably restrict it a lot into just these really, really, really high intensity areas for that upper limit of my annotations. I usually don't adjust these values until I've maxed out my training. There will be a point in machine learning, because it's just a pixel classifier, right? It uses random forest algorithm. It doesn't have any concept of object shapes. So there will come a point in machine learning where you've done as much annotating as you can. It's just going to reach a limit at some point. And if you still can't get it and it's just not going to train anymore, then you'll have to probably go to a deep learning route. But you would want to hit that level first. And usually it's totally data dependent. You'll just have to kind of test it yourself. And the way that you'll test it is, let's say you have like 100 annotations in background, 100 annotations for your class. And let's say I really want to include this as background, but no matter, if I then draw this all as background and it's still not changing the result, that gives you an idea that your model's kind of maxed out on the learning potential that it has. Then at that point, you can go and see if adjusting these values or if doing some pre-processing beforehand can kind of help it. Okay. All right. And then once your object is done training, you'll see this red check mark right here, and then this green check mark, and it's saying the model has finished training. You can now go and open it in a pipeline. Okay, I'll do that in a second. But then if, for example, machine learning doesn't work, we can then do this here. And then let's say, I think we should be able to also add these in together. So let's say I want to now take all of my annotations from that machine learning trainer, say it didn't work. Again, I'll have to check. I don't know. Lai, do you know if you guys have the deep learning trainer local? If not, I can look it up myself.
I think we have.
Okay. So then if, let's say you try your machine learning training and it's just not working, you don't have to re-annotate everything again. You would go into your objects table, and I don't think I went over this yet, but these are all from my machine learning trainer. You can see that these are all of my annotations that I have. And I can go through and say, give me all of these, and now blah, blah, blah. add it to, you'll have to find, you know, which one's the background, which one's the class. But then instead of having to re-annotate everything, you can just go put them in like that, and then just do a training like that. And then the training does take some time, depends on the speed of your computer, the size of your data, and how many annotations that you have. There will be a little, maybe I can show, oh, because I have no class. I'm going to do something just really random just to show you what it looks like. But when I hit this train, it will then say, we have this, you know, use all of the image sets. So in this case, I just have annotations on 2 different image sets. On just one of them. It's saying, you know, you just have annotations on one, just use those. You have the selection of using all planes that have backgrounds or just any planes that have anything on it. And then you can pick the kind of the channels that you want to train it on. That would be here. It's going to give you a warning if you try and train it too early. It's saying in this case that you just don't have a lot of objects for this class. And it's saying that it recommends at least 50. This is just a recommendation. I usually do just get to that 50 mark. And again, it's not a it's not going to not train on it. It's just the quality of the training is better with the more annotations that you have. So then when you hit train, maybe I'll try this. It might give me an error because I just don't have a lot. In that case, it is. Okay, so we would need to add more annotations, but once you hit train, it will give you an error if you don't have enough. And then when you hit train, there should be a window that pops up and it says that one, that we need, okay, at least 5 training images. But then there will be a little GUI that pops up and it'll say, you know, epoch 1 of 400. Here's the result of the training for this first epoch, second epoch, etc. And then it'll give you a status update on how much training it has left to do. If you stop the deep learning training early, it will, you know, if you stop it at like 200 out of 400, it will still have that first 200 epochs included in the training, and then you can run it at that point. So if you find that maybe it's doing really well and it starts to level out and it's like only halfway done, maybe it's probably easier to just cancel that training or stop the training early because it doesn't seem like that extra hour of training is improving it. So why let it run for an extra hour then? And then once it is done in training, you can then, same thing with that machine learning trainer, you can then open up in a pipeline. Okay. You can change the brush radius here. And that would also scale based on the size that you are, or it wouldn't scale to the size of your viewer. It'll just be the static diameter, the static radius that will scale to the viewer here. Not add those. Okay. Go ahead and stop this. I'm going to delete for this sake this objects here. Don't want that. Okay. And then if you have any questions, if you're trying it in your own hands, there's this manuals that we have here, as well as a help menu here. The help menu is going to be, you know, it's the same interface as the manuals. So let's say I needed some help with this deep learning trainer. So I would type in that into the search bar up here. I see right here this deep learning trainer, and then it has my images here. So this will kind of go through again that information. It'll give you some, you know, keep in mind. And it sees, I guess one thing I'll point out, it says creating multiple trainings for each individual class of interest actually does result in better models rather than using one model for multiple classes. So I guess I will really reiterate, if you want to segment out like 3 channels, one for DAPI, one for the red, and one for the green, just do one training for each of them. Okay. But yeah, all that information will be contained in here. For some cases, they will go into the math behind it. This is that GUI that I was talking about before. So you can kind of see what the performance of this model is. You can see the epoch that it's at. You can change the amount of epochs that it has. You can change the training quality. It can kind of tell you a little bit on how this deep learning trainer works. So it's saying, you know, tiles of 5 by 12 by 5 by 12 are being prepared. It gives you a little bit of input of what this value actually means. Some links to other information here that might be relevant. And then for some cases, they'll also include papers, links to papers. This deep learning training is developed internally, so this is where the information will be. But let's say there is CellPose, for example. I'm not sure if anybody's familiar with CellPose, but that's an open source deep learning segmenter that's already been pre-trained on thousands and thousands of images. This was developed by Genelia scientists. And these are their publications here. So for some operators, you'll get information. You'll also get a link to that paper too. And this is useful if you need to, I mean, even the papers are useful, but all this information is useful if you're trying to report your methods. Rather than saying we use deep learning trainer in Arivis to segment our objects, right? That doesn't really mean a whole lot to people who don't use the software or know what it's about. But you can go back to that help menu and say, this is how it trains it. You can then go a little bit more in depth if you need to and report that in your methods.
So the Arivis use the CellPose?
Yep, CellPose is native to Arivis, so it's an out-of-the-box operator. You don't have to download any other like Python script or anything like that unless you want to develop a custom CellPose model.
So when we do the machine training you just did in the Arivis, the result will be the same as we do the same thing in the CellPose?
I don't think it would be. The reason being is because there's the machine learning trainer is really just it uses a random forest algorithm, and it's essentially just a really nice pixel classifier, but it doesn't have any concept of shape. It can't learn shapes of objects, whereas CellPose is a deep learning trainer or deep learning model. It has been trained on tens of thousands of images, fluorescent images, regular everyday images. And it'll tell you what those models are trained on, but it does have a concept of shapes. So usually for my go-to when I'm thinking of segmentation is one, can I get it with just a really easy like threshold-based segmenter? One value, segment everything of interest. And that's what I did for this these green objects here. That's actually what I used, is just a simple intensity threshold because I wanted to get the outline of the entire cell, which you can't really make out. So I did some smoothing, some correction, and then that's how I got these here. But let's say that intensity didn't work. My next step would be going to machine learning. So it takes a little bit more time. There's a little bit of investment. But then if machine learning doesn't work, then I'll probably go and try CellPose because it's just an out-of-the-box operator. Maybe I can show you. Yeah, I use it here. So what I've done here is you put CellPose in here. You pick the model that you want it to train off of. So in this case, it's a Cyto2 model. We have a CP model, CPX, Cyto2 nuclei. And then this external model is if you wanted to create your own custom CellPose model. And then you're really just giving it the size of the cell diameter, a little bit of smoothing. There's additional options here for, again, if you want to kind of fine tune some of these results. But this is, you can see the preview just takes a couple of seconds. and then you have a good idea if it works or not. And then if that cell pose still is not getting you the results, then I would think about doing either a custom cell pose model or then doing deep learning segmentation. So kind of like a tier. Start with the easiest to implement and then get into the more advanced. Okay.
So all those trained models are saved in the .sis file, right?
Yep. So if I were to, let's hit save. Let me make sure I have it. Something saved here. Oh, I deleted them. Let me do it real quick. So I'm just going to put gibberish down right now. Yada, I'll do training. And then I'm going to just save the file, exit it out, close this, reopen it. And it's saved to the .sis file. So all my annotations are going to be saved. The training is going to be saved. Any of these image sets that I import are all going to be saved to the .sis file. So that's why if you do decide to go the route of uploading all your images to a single .sis file, which is personal preference, if you do go that route, usually I'll rename this file. Instead of being that first image that I uploaded, it's just going to take that file name, right? I'm going to rename this to now be representative of my experiment. So I can import all my files, keep all of those 18 images separate as their own native files, but then have one .sis file that has all of my trainings, all of my image sets. It's called experiment A, control, experiment, whatever you want to name it. All of the models are going to be saved within it. The pipelines that I run are going to be saved within it. And then any of these objects that I have segmented out. So for example, these objects that I've already done before, I think I did this last week. These are all going to be saved as well. And if I go and exit it out, or if I take this, send this to another member of my lab, they would just be able to open that .sis file. And it's all saved within this. Let me go to it. Where did I save this? Oh, I saved it. Oh no, I saved it here. All of these are going to have a cache file, a metadata file, an objects file. So, and they'll all have the same name to begin with. So as long as you take all of these and then transfer them over, someone else can just load this SIS file. And as long as this .objects is in the same folder, cache is in the same folder, etc., it'll then populate your pipeline, objects, trainings, etc. All right. I think that covers help menu. Oh, one other thing. I actually think this is really useful. In the manuals, there is this guides for, let's say you're trying it out for the first time and you want to trace neurons, for example. I can go how to detect neurons. This menu is going to pull up a whole PDF that is going to tell you how to run it. And it's going to give you an example pipeline. There's even a sample data set that you can download. So right here, if I click this link, I can download this file here. So for any of these examples pipelines that you want to run through, it's going to give you the data set already. Which is really nice because then it'll walk you through kind of their logic behind it. It'll walk you through the reasonings for why they set those values, best cases, kind of, what does it mean to adjust the split sensitivity? What does it mean to change the threshold base or the pixel intensity, the threshold value? What does it mean what do my results mean? What if I want to color these objects based on, in this case, it's branch level? What if I want to do it based on, any of that stuff is all going to be contained right here within this example PDF. And that's going to be for a few different, there's quite a few on here. So these are all different examples that all have their own data sets associated with it. Okay. The last thing I'll point out is this preferences. The one thing, and we can also make sure that we have it loaded and it's working fine on the workstation that your team has it on, but you definitely want to make sure that if you're on a workstation that you're enabling GPU acceleration, because this is going to be, if you do any deep learning, machine learning, or 3D rendering, which is probably going to be most of the time, you need this to be enabled for the program to fully utilize your GPU. So if this is not working, this enable GPU acceleration will either be unchecked or there will be a warning sign saying, update your driver or something like that. I think that covers. Oh, the last thing is we don't have it officially planned for walking through, but maybe if there is general interest or if someone just wants to reach out afterwards and they're curious on how to run Python scripts within Arivis Pro, we do have the option to interface and run Python scripts natively within Arivis. So if there is, let's say you have a pipeline and you have a Python script, or you want to analyze your data and you have a Python script that kind of edits your data and stitches it, does all this pre-processing, and you want to keep that and not have to reinvent the wheel in Arivis Pro, you can just say, run this first pipeline, give me this output, and then with that output image, now run it through my pipeline, with all having to do a save, import into Arivis, now run it. Okay, so there's some flexibility there. These are your open, save, and close buttons, your pointer, your zoom tool, pan tool, grip, move. You can also take this and move it on the window. We're in this viewer right here. I mentioned it before, but we have this manual draw objects. So I want to draw this. Have that there. Get rid of that because you don't care. You can also move those objects too. And then one of my favorites is this magic wand tool. So it actually works in 3D as well. So what this is doing, it has this bounding box right here. And based on where I'm placing, like you see that plus button, wherever I place that cursor, it's going to take that information. It's going to compare that intensity information to the bounding box, and then it's going to determine what the segmentation should be. So I find this object right here. You can see if I go to just a really bright area, it's only going to say, well, there's only a really bright area in this tiny little spot in the entire ROI. But if I go and I pick a lower intensity region, like right here, and I hit go, let this run for a second. It actually works in 3D as well. So now we have a really quick segmented 3D object. And this could be useful if you I get like new images. Sometimes I'm just really curious on like the volume of, I don't know, if I was really curious what the volume of this is without me having to run a pipeline on the whole image set and do all that, I'll just take that magic wand tool, run it on here, get a quick answer. Same thing if you want intensity or anything like that. Okay. Then a measuring tool. If you're curious about the size of objects, can also do the area, or so an ROI here, or we can do like an area or something. Can do it really crazy if you are so inclined to. Actually, I don't want to do that. Okay. There's this trace tool. This is for the case of if you're doing neuron tracing. Kind of in that example data set that I showed you, you have the neuron cell body, the dendrites, axons, neurites extending out from it, and then you saw it was colored based on branch order. If there was a case of where, let's say, the branch order is messed up, it's not, maybe these two dendrites crisscross and the tracing kind of messes that up, you can go and edit this, and it just literally looks like little nodes on the branches. So you can just say this node should be here, this node should be here. You can just drag and drop and click to kind of correct it. If you do any tracking of objects, so I mentioned before, there's some people who've done like a tumor cell T cell assay. I know that's pretty common. If you want to track those T cells, you would then get it into like a lineage. So it's a object 1, time point 1 is here, time point 2, and it'll have a little line connecting these. And then if they, let's say you have these objects that split, you'll then see a node with them splitting into now 2 different objects. So you can kind of track a lineage. And then same thing, if you need to change the tracks, you can just drag and drop them to the correct track if needed. Take a screenshot. This is going to take an image of this ROI that we see in here. This button here is going to zoom to fit. So this object in its entirety is going to fit to the ROI that we have in this background here. Zoom in, zoom out. If you want to change the look of objects, and there's a couple ways that you can edit this. So if I go and I hit this objects table right here, I'm going to pull out all the objects again. And let's say I wanted to, no, I don't want to do that. This. Okay. Let's say I wanted to make these DAPI all different colors. So I can see my DAPI right now is colored cyan. Do random. So now each one of these are going to have their own color for individual objects. Maybe I want to color them based on, they're all going to be kind of the same, but if I wanted to do it based on volume yeah, this is 3D. So volume, you can see what that looks like. Not a whole lot of discrepancy because they're all kind of the same size, but we can also get like a spectrum of this too. So if you want to, maybe you have like a wide, diverse array of objects that are different sizes. So maybe proteins, and some proteins are individual puncta, and some proteins form these really large complexes that get super large in size, and everything in between. You can then scale the data colors based on any of these features that we have here. So it could be useful for visualization purposes. You can also change the look of these to be glass-looking objects. You can do it just to be just outlines. Whatever you want. And then we have this little scale our legend down here. That'll show you what the color is referenced to. I'm wondering if, okay. I think that covers objects. Okay. Go into the pipeline here, or the analysis panel, I should say, and let me hit home really quick. So when we hit this analysis panel, it's going to pop this open here. And the same thing as I mentioned before, there's this help menu, manuals, and all of these here. Those same pipelines are also going to be loaded down here. You would just need to either import your own image. So if you're doing neuron tracing, just import your own image of a neuron. Or if you want to download that demo data set, you would then just go to this help manuals and download it from there. Okay. I've already gone ahead and created this. Let me go back and change these to opaque again, just so they pop a little bit more. I already created a pipeline and ran it, as you can see. So what I would recommend is usually just start with one of those example pipelines, because then you can get an idea on what at least the order should be. And you can always work off, add, or change it up however you want. So if you do, for example, like a neuron tracing sample pipeline on your own data, and you find it's just not that good, maybe it's getting like 80% of the way there, maybe add to that sample pipeline right beforehand a pre-processing step that does a little bit of background correction to improve the contrast of those objects. So something like that, I think is good to start with, like an example pipeline, and then build off of that. Whenever we import or start a new pipeline, it's always going to ask you where you want your ROI to be. And that's going to be, what do you want to run your pipeline on? Current image set means that, so this entire image set that I have loaded here, so that's going to be all of the Z-planes and the entire ROI, so the entire dimension of the image. We'd also have all of our channels loaded, but if you just wanted one of these channels, same thing, scaling. Scaling would be, if I did it to 50%, for example, the scaled version is going to be essentially taking every other pixel and then scaling it down based on that. This could be useful for, let's say you have like, again, like a light sheet image, you've imaged it in Nyquist, and it's the super high resolution image. Maybe you don't need all of that resolution to see your objects of interest really well. So if you downscale it by half and you can still make out your objects really well, then that's going to save you a ton of processing time. And those objects are going to be overlaid back onto your original data set. So even though we did scale it down 50% and those objects were created on it, you then would get that those segmented objects overlaid, and you would still be able to pull out the data at 100%. You can also choose just to do a current view. So current view would be like, if I zoomed in really close, this is what it would be analyzed. It's this current, everything that I'm seeing in this viewer right now. If I did it on current plane, it's going to be this entire plane right here. So Z slice 17. Current time point, there's only one time point. So in this specific example, current time points and current image set are going to be identical, or there's custom. So if you just want a small ROI, plane just at a certain time point, etc. One of the other nice things is, let's say I want to just run an ROI or run a pipeline on an object of interest. You can see these bounds here, but you can also see that we have the option for object. So when I have this object selected and I pick this bounding box here, it's now going to analyze it on just this ROI here. So that could be useful for some applications as well. All right, and then once we import this data, do it really quick there. Actually, let me do it, because once you start it, you're not going to see the objects anymore until you run it all the way. And I see now it's mad at me. Let me pull those back up in a second. Maybe I'll cancel this just to, okay, there we go. And then when we're building our pipeline, I always think, what is my goal that I'm trying to achieve here? So this is an example data set that we have in our hands. And from here, what we wanted to do is, one, get each of these objects or these cells, number one, how many do we have? And we can count that by either counting all of our DAPI up, or we can do it by counting our expanded cell objects that we have here. Right, so both are 15. Then I also knew that, so when I'm thinking of, I want to get all of the cells, and I want to see the intensity of this red channel within these DAPI and the intensity of the red channel within the cytoplasm of the cell. That means that I need to be able to segment out this entire cell, right? Because I need to be able to kind of get these measurements. So that's where I'm thinking, okay, let me first find a way to get all of these cells out here with this expanded cell. Now, how do I get this DAPI? Okay, now I'm going to do maybe a subtraction of this expanded cell minus this DAPI. So the only thing that I'm left with is just this green that's not overlaying with this gray looking DAPI here. And then I can get my intensity measurements for the red channel based on that. So whenever I'm developing a pipeline, that's kind of what's going through my head is what am I trying to analyze, and think about how can I, what do I need to segment out in order to get those values. And so yeah, that's kind of where I went with starting with the STAPI here. I will also point out, so we have these different models here. You can also create your own cell pose one. And then for each one of these, I did show you guys before, but for all these operators, they'll all have these preview buttons. And again, it will scale and be more accurate the closer I am. So the further out I'm at, it's probably going to look terrible if it actually runs. Well, I guess it's kind of the same. Okay. But this is like a really nice way of when you're choosing which settings to create, right? So I already knew this was a good setting because it got me advanced. But what if I did like 5, for example? This is going to take a little bit to run, right? Because it's deep learning. Well, this 5 looks terrible. This is definitely not the result that I want. Maybe I stick with 15, where I knew that the 15 inside of 2 is good. But what if I ran it like with nuclei? So technically, yeah, these are nuclei, but is that the best model for this? You can see it kind of messes up a little bit here. Here it kind of split. So maybe that is not the best. Maybe I don't want to use the nuclei model. Same thing with CPX. So this is just a way of, without having to commit like however long it's going to take to run it, this gives you an idea on what the results are going to be beforehand. Same thing with, in this case too, it's for the red channel. Etc. Okay. We can probably spend some time with, if you guys have questions, if you're trying it out in your own hands and you're building a pipeline, I'm always available through email for if you have questions on, I'm trying to get this. Here's a screenshot of my results. It's not looking as good as I'm hoping it would be. I can give you some advice or help you troubleshoot it via email as well. Or if like you're really, really, really struggling and we can't resolve it through email, we can get on a quick call and kind of talk through it. But I would recommend just play around with these pipelines, look at those that help menu for each of the individual operators to learn a little bit about them, and then those PDFs of those example pipelines and running it through that from start to finish. Yeah, I think the best way to learn is just kind of get your hands on it and then just trying a bunch of things. But always here to help support too. Okay. And the last thing I'll talk about before we're going to transition for the last 15 minutes into Arivis Cloud. Then I have a couple of minutes after the hour for any specific questions. If we don't finish by 12, I can stay a little bit later. The last thing I want to point out in this analysis panel in Pro is there are 4 main steps when running a pipeline. And you're always going to run them kind of sequentially. So for example, what I mean by that is if you need to do image processing, so do any sort of background correction, do any normalization, denoising, etc., you're going to do all of that first. So if I want to clean up my DAPI channel, then my Mito red channel, I'm going to run maybe I'll start with like a new pipeline. I'm going to first do like a background correction on this channel. I'm going to do a background correction on this red channel. And then I'm going to do like a denoising on both of these. Right? So we would run first all of those pre-processing steps first. The pipeline, once we run these steps, it's not going to let us revert back. And so you'll see that when I go and I run it, probably should have just picked a current view. It's not taking that long though. But you'll notice when this finishes up that once I've done this result storages for this section, when I go to add an operator, it's not going to let me do any more of that pre-processing. It's saying the next step is segmentation because you've already done that pre-processing. So That's also something to keep in mind. You'll have to do all of your segmentation, all of your pre-processing kind of in order. Then you would then say, okay, I want to do my segmentation of this blob finder to get the DAPI, and then doing a cell pose to get the whole entire nucleus. Then I want to do a deep learning algorithm to get the Mito red channel. Then when I run all of that, it's going to say, okay, not all operations are available because you've already ran the pipeline. Now I'm going to do the object. So then this would be, all right, I have all my objects segmented. I have my red channel segmented. I have my DAPI segmented. Now I want to get some measurements. So then we can do this. Maybe I need to kind of do some region growing to fill in some blanks to get some more stuff. Maybe I want to filter my results a little bit more. Maybe I want to create a relationship between these objects. So maybe I want to find the distances between two objects. So then you would run all of those. And then once that whole step is done for everything you want, you can then export these. Okay. And then when you're done, you have the option here on how you want to store these objects. You would then have these objects being created. Let me cancel this really quick so it pops back up. And then for all of these, we can now go into the objects table. And let's say I want to get, so I have these things called cell compartments. So I created these associations where I said, okay, so for this cell, you can see that this, anytime we have something called a compartment, it means that they create a parent-child relationship. And so that means I said my parent, which is the larger object, is going to be this entire green object here. And then the children are going to be everything that's inside of it. So you can see we have these individual objects all highlighted and are saying that are a part of it. So these are going to be all the mito reds, the nuclei. So then when I go and I find this DAPI here, I now see that's what's highlighted here. So then I can say within object one, the DAPI associated with it has a, this is a 3D object, but I know the surface area of this is 558. I know that if I go to now this cell right here and I look for wherever that DAPI is, right here, I know this is the surface area of it. And anytime you double click on any of these, whether it be through clicking manually on the object, it's going to bring you to that. So if I click this, it's now going to bring me to, now this is 4. If I click on this, it's going to bring me to parent 12. Or you can go and say, hey, I want to find what the largest object in my cell, my image is. Let me, without having to kind of guess and look by eye and take forever, let me just do a volume, sort this by volume. Okay, I know that this is the largest cell that I have, is this one right here. This is the second largest one. And then you have all of the other measurements down within here. And we can measure over 200 different features. And these are all within here. So intensities of these. Maybe I want to get all of the underlying intensity of the green channel underneath this, or everything in the red channel based off of this green object. You can also create custom features. So I use this all the time for, I have a ton created here, but this is used, so I've used it for distance calculations, and I've used it for creating ratios too. So if you wanted to get like a volume over intensity ratio, you can create that yourself. So it's really just saying create, compute. Then I say I want, to get a ratio, object A, object B, or you can get any of these other objects here or values here. Right. And then when you're done with all of this, I also want to mention you can get summary of all of these too. Summary outputs, if you just kind of select everything. But then when you're finally done with everything, you can just export whatever you want. So all of these measurements, you can export it as an Excel file. And then you can go, if you use R, if you use C++, or any sort of statistical software, or just even using Excel itself, you can then take that and do all your data there. Okay. And that is a pretty kind of is going over the basics of Arivis Pro. There's going to be a lot of little things that like little questions that come up as you're playing around with it. The software has a lot of flexibility. Again, we're with you to kind of, if you have a problem and you can't get it with some of these out of the box solutions, it's flexible. So we have a lot of opportunities to really kind of tailor and create a pipeline, use some imagination, and figure out how we can get the answers if it's not necessarily quite simple. Okay. All right. So I'm going to transition to, as I get loaded my Arivis Cloud. In 1 second. Does anybody have any questions for me while I'm getting that loaded?
Yeah, quickly. When you save, so let's say you move a CZI, you transform a CZI into SIS format, and then when you move it back to CZI, do you keep all of your metadata?
Yes, if it is, well, if it's importing and it's keeping that metadata and you want to export it back again, it would keep the metadata.
Okay.
If you import as like a TIFF, and because it doesn't necessarily,
Yeah.
all the metadata, it's not going to populate it.
Okay, thank you.
But if you take that TIFF and then you kind of manually edit that metadata yourself, and then you export it as a CZI, then you would, yeah, it'll stay attached with that file.
Oh, very nice. Okay, thank you.
Yep. Alrighty. We can, I'm going to go over Arivis Cloud now. I think it's really not super, well, I'm not going to say it's not super hard, but it's pretty basic in terms of what it's meant to do. Let me close off some of these things here. So when you log in to Arivis Cloud, and I think, Lai, do you have access to Arivis Cloud? I also forgot to look that up.
What is the question?
Do you know if you also have Arivis Cloud as well?
I have to check. I haven't really.
Let me go. Let me check really quick. I think you do. Let me check. Well, we're getting that. But essentially with the Arivis Cloud, I think you do. It's not updated on my end here. But I think you do, because I know we were talking about like before, I believe. Let me go ahead and share my screen again. All right. So when you log into Arivis Cloud, if I'll go to this homepage here. Oh, I guess you don't. And that's actually fine because, sorry, Arivis Cloud is really the same thing as this. Let me go back and share my screen again. The deep learning trainer, which I think you guys do have access to. So that would be this deep learning trainer here. It's kind of the same exact thing. You'll just go and you'll annotate your objects of interest and see what the result is. And again, the deep learning trainer is the capacity that it has to learn is you're probably not going to reach that capacity unless you do like thousands and thousands and thousands of annotations. So that would be the only difference between cloud versus deep learning trainer, this local one here, is that you're either using cloud resources or you're using your own computer. So if you have, the training will kind of take you a little bit of time. I think for this data set, when I trained a deep learning trainer, it took me about, I want to say 2 hours to train it. But again, it's not a super, 500 megabytes, give or take? Not a super large image, but if you do have an image that is, a terabyte, it might take a little bit more time. And then alternatively, the deep learning trainer here, let's say you don't want to use that, and you kind of want to go with the cell pose route, like a custom cell pose route. The way that we can do that is, I go and I start a new one. We can do this load external model. There's a file, these ONX files, we can load them, and maybe I have one already. Let me see. I do not have an ONX file. Unless it's in here. I do not. But the same exact thing that you would be doing for doing this machine learning, or no, not machine learning, this deep learning trainer, where you're going through either machine learning or deep learning, when you're going through and you're actually annotating your objects. So what cell pose, if you wanted to create your own custom cell pose model, you would go into Anaconda. So that would be something, it's a IDE for Python. If you guys want to get it set up, we can work with you and get it set up on your computer. And this way you guys don't have to worry about setting that all up. But you would just go into Anaconda, type in cell pose or whatever the function is you'd have to call, and then you would have a GUI that would pop up. You would load your image. You would then run in that GUI one of these pre-built models. So this set of 2, for example. So something like this. And then the benefit of this is that when I run this, right, this is already segmented out for me. This is saying, hey, we've already got these objects. So whereas if you're building a deep learning model from scratch, you're going to have to annotate everything from the beginning. With this cell pose, like a custom cell pose model, you already have all of these already created. And then you would go into the GUI and then say, hey, it messed up on this plane a little bit. This is what it should look like. It actually, and then you would go and you would literally just annotate it the correct way. And then once you annotate it, it's going to update and say, okay, let's do another retraining, and then it'll correct it. And then you would just go through a few more planes, see how the result looks, and then if it's messing up in another spot, go and correct it. And then the result would be you would have to do a fraction of the annotations. And you're already starting from a deep learning model that's already been trained on previous similar images before. So this can save you some time as well, rather than having to start from scratch. And again, that's something we would help you get set up. And then the cell pose is it's included with just the base Arivis Pro software. So. Okay. All right. We have about 5 minutes left. Does anybody have any questions about anything? And then let me look at what is on the schedule for next time, for Thursday.
So this should be the neural tracing.
Okay, yep, I'll bring some data sets.
Okay. I guess we just need more practice.
Yeah, and if you guys don't get around to it until after next Thursday, I'm still available. As I said before, the onboarding is kind of like this custom training, but we still, I'll still have meetings with you, and we would still work with you to help fix anything. This is kind of more of like getting your feet wet, getting like started, so you have like a good starting point. This way, you're not just looking into the software and you're totally confused, overwhelmed by everything. So,
Okay.
yeah, if something comes up even after next Thursday and we need to have another meeting about it, we can do it. We may even have. I think we kind of left the last day a little ambiguous. So maybe if we go like after this Thursday and next Tuesday, if there's like a really strong interest for like a particular application that people would be interested in, we can then tailor that last Thursday to that too.
Okay.
Any other questions? All right.
Yeah, I think that's all for today. Yeah.
All right. So,
Yeah.
and then just to confirm, so I've got your license here. So it includes batch analysis, exchange tools, neuron tracing. So we'll go through that next time. And then visualization analysis. So the deep learning trainer won't be on there, the local deep learning trainer, but the custom cell pose model essentially is the exact same thing, and it works a little bit faster. So maybe we can set up a separate time outside of these trainings just to get it set up for you guys. Have you guys already set up Arivis Pro on a workstation yet?
Yeah, we have a workstation around it.
Okay. Double check and make sure that it's running that CUDA. It has support for CUDA for that.
Okay.
Under settings and then machine learning, you'll see if it's checked or not. And then the error usually will be you just need to update your driver if it has like a yellow warning sign.
Okay.
Okay. All right. So for next week we'll go over neuron tracing. Maybe I'll also go over some pre-processing beforehand because I know neurons sometimes can be. I'm a neuroscientist by training. I've done a ton of immuno. I know sometimes really fine processes can kind of look blebby, and so sometimes doing like some pre-processing can help kind of pull out and improve the contrast of those objects. So
Okay.
cool. Looking forward to Thursday. Yeah, if you have any questions in the meantime, please feel free to reach out.
Okay. Thank you.